Imagine a hacker actually getting past your $1 million perimeter firewall.
Yeah. They finally get inside and they just think they've won.
Exactly. They think they've hit the jackpot and they have the complete run of the place.
But they don't.
Right. Instead of this playground of, easily accessible sensitive data, they just find themselves totally trapped.
Trapped in a digital closet, basically.
Yeah, completely unable to move a single inch in any direction.
Yeah.
I mean, it's wild. Welcome to the WeCyberYou Unlocked podcast. We are so incredibly glad you decided to join us today for this deep dive.
It really is great to be here.
And hey, before we jump into things today, do us a huge favor. Hit that follow button on whatever platform you are listening on right now.
Yes, please do. It helps a lot.
And make sure you explicitly go and visit WeCyberYou.com for a ton of extra content just like this. That is WeCyberYou.com. You will not want to miss it.
Honestly, the scenario you just described, trapping an attacker the very moment they get inside, that is exactly what we are unpacking today.
It really is a massive fundamental shift in how we handle modern cybersecurity, isn't it?
Oh, totally. It's a game changer.
So today, our mission for this deep dive is to completely demystify this concept, because it's frankly reshaping how the entire digital world protects itself.
We are digging really deep into the mechanics of microsegmentation firewalls and zero trust security.
Right, because the goal here is to figure out how modern networks are actually stopping hackers who have, already managed to bypass the perimeter.
Because traditional network security, it's fundamentally broken.
It really is.
Yeah.
So what does this all mean?
Well, it means we have to completely change our mental model of how networks operate on a, foundational level.
Right, from the ground up.
Exactly. For decades, organizations relied really heavily on this classic castle and moat strategy.
I love that analogy. You build a massive, heavily fortified wall around your data, right?
Yeah, and you just assume that everything outside that wall is dangerous and malicious.
But everything inside the wall is safe and trusted.
Which is a huge assumption.
Yeah.
And in network terms, that massive wall is the perimeter firewall.
But that just isn't enough anymore, is it?
Not even close.
Yeah.
Historically, to try and break things up inside that wall, network engineers have used things like VLANs, standard routers, and access control lists.
Just to sort of carve the network up into these really large segments.
Exactly. So maybe you have one big segment for the human resources department and another completely separate one for engineering.
Okay, yeah. And while dividing the network into those large subnets reduces a little bit of the risk.
It's essentially like drawing chalk lines on the floor of a massive warehouse.
Chalk lines. Wow. So it leaves this glaring vulnerability.
Huge vulnerability. Inside those specific departments, you might have dozens or even hundreds of systems that can just communicate freely with one another, completely unchecked.
Because they're sharing the same trusted space.
Right. They just assume everyone else in that space is friendly.
Which, that leads directly to the typical attack path we see over and over again.
It's honestly terrifying when you think about how common it is.
It is.
Yeah.
It almost always starts with something incredibly simple, like a phishing email.
Yeah, an employee accidentally clicks a bad link, their workstation is compromised, and then malware just quietly steals their session tokens or their credentials.
But that initial compromise, that's just the foothold, right?
Getting in is literally only step one for the attacker.
Exactly. From there, the attacker starts scanning the internal network.
And because the internal network implicitly trusts that compromised workstation, the attacker can just look around.
They compromise additional servers, they escalate their privileges, and eventually they just find their way right to the highly sensitive customer databases.
They just walk right in.
It makes me think of like a giant high-security office building. The perimeter firewall is the heavy security at the front door.
You've got the guards, the metal detectors, all of it.
Right. But once you badge in and actually get past the lobby, every single internal office door is just wide open for you to wander through.
What's fascinating here is the concept of lateral movement.
Lateral movement, that's the industry term for wandering through those open internal office doors, right?
Exactly. Traditional security is so intensely focused on defending the front door that it just blindly assumes trust once you are inside.
But in today's threat landscape, assuming trust is just a fatal flaw.
We have to shift our perspective entirely. It is not always about stopping the initial breach.
Because someone, somewhere, is eventually going to click a bad link.
Always. The focus has to shift entirely toward containing the blast radius.
Containing the blast radius. Okay, that makes a lot of sense.
If an attacker compromises a single workstation, They should be trapped in that one tiny area.
Right. They shouldn't be able to move laterally across trusted networks and access your, highly sensitive database servers.
We have to completely take away their ability to pivot.
Which brings us perfectly to how we actually go about locking all of those internal Office stores.
And this is exactly where the microsegmentation firewall comes into play.
Okay, break that down for us.
It is a specialized security architecture that divides a network into incredibly small, isolated security zones.
So instead of protecting an entire subnet of 50 servers.
It isolates individual resources.
Mm.
We are talking about virtual machines, containers, and Kubernetes pods.
And each of those has their own personal, airtight security boundaries.
Exactly. The logic completely shifts. In the olden days, a firewall asked, can this IP address use this specific port?
Right, very basic routing logic.
But microsegmentation asks a much deeper question. Should this specific workload operating under this specific user identity be communicating with that specific workload right now?
Okay, let's unpack this way, because if I am understanding this correctly, instead of having one big firewall managing the network, we are effectively deploying thousands of tiny firewalls around every single digital asset.
Yeah, that's basically it.
Isn't that an absolute administrative nightmare?
Well,
I mean, if a human being has to manually write rules for every single connection in a massive enterprise, that would take centuries.
oh, if humans were doing it manually, yes, it would be impossible.
Right.
But the initial phase of deployment relies heavily on automated asset discovery. That's step one.
Okay, so the system does the heavy lifting.
Exactly. The firewall system deploys tools to identify every single protected asset out there. Servers, virtual machines, cloud workloads, user identities.
It just sees the entire board automatically.
Yeah. Hold on, I know what you're going to say.
Well, yeah, I have to challenge you on that. You say it discovers everything automatically, but automated systems and AI, they get things wrong all the time.
They absolutely do.
If this smart system hallucinates a dependency or gets confused about what an application actually is, couldn't this automated firewall accidentally shut down my company's payroll server right on payday because it misidentified a legitimate connection?
That is a very valid concern, and it is exactly why you don't just flip a switch and start blocking traffic on day one.
Oh, so there's a buffer period.
Step two is a passive communication mapping phase. After the system finds the assets, it just sits there and watches.
It just watches.
It monitors traffic out of band so it doesn't impact performance, and it observes normal behavior over weeks or even months.
Okay, so it learns who communicates with whom, which applications are involved, and what normal traffic volumes actually look like.
All right. It's building a massive, highly accurate visual graph of dependencies based on real-world data, not just guesses.
Okay, so it builds a baseline of what normal looks like over time. That's step two. What's step three?
Step three is policy creation. Once you have that map and you actually trust it, administrators step in and start creating policies based on that data.
Let's look at a real-world scenario for this.
Okay, say you have an application stack. An administrator can set a granular rule that says the web server is allowed to talk to the application server over an encrypted HTTPS connection.
Right.
And the application server is allowed to talk to the database server.
Makes sense.
But they explicitly block the web server from talking directly to the database server.
Oh, okay. And I assume they rigorously block user workstations from talking directly to the database, too.
Exactly. Because under normal operations, a regular user workstation should never need raw access to a backend database.
So, by creating that strict, explicit policy, you are severing the exact path an attacker would use to move laterally.
Spot on. That explicit authorization is key.
I want to try out a new analogy here.
Let's hear it.
Instead of the open office building we talked about earlier, this microsegmentation approach feels more like a modern hotel keycard system.
Oh, I like that.
Right. Your specific key card only opens your exact room, maybe the elevator, and the ice machine down the hall.
Yeah.
But if you try to take that same card and swipe it on the room right next door to yours, it instantly rejects you.
That is a highly accurate way to picture it. You are granted explicitly authorized pathways and absolutely nothing else.
And on a technical level, the way it achieves that key card functionality is incredibly robust.
Right. It really is. It relies on cryptographic workload identity.
Which means
The firewall doesn't care about what IP address the server happens to have today. It verifies the actual cryptographic signature of the application requesting access.
usually through something like mutual TLS.
Exactly.
That is a crucial distinction. It's not just looking at a list of numbers, it's demanding cryptographic proof of identity.
Which rewards the system with much tighter security. And that brings us to step 4, local enforcement.
Because the policies are enforced directly at the local level, right?
Right.
Right at the workload.
Yes, it isn't sending traffic all the way back to some central hub across the network to be checked.
So how does that actually work mechanically? How does it stop the traffic before it hits the broader network?
Well, instead of routing traffic to a central choke point, specialized software agents are placed directly inside the virtual machine's operating system.
Okay.
Or security controls are embedded right at the hypervisor level.
And the hypervisor is the underlying software that creates and runs those virtual machines, right?
Exactly. So when a malicious packet tries to leave a compromised container and head toward your database, that local agent or hypervisor intercepts the data packet the exact millisecond it tries to leave the virtual network interface card.
Wow. So it gets stopped at the literal source.
It never even gets the chance to touch the physical network cables.
That's incredible. And then step 5 is continuous monitoring, right?
Yeah.
Once those local rules are in place, the system doesn't just go to sleep.
Right. It constantly monitors everything. It evaluates new workloads spinning up, configuration changes, user activity.
Just make sure everything stays locked down.
Yeah, and if an unauthorized connection is attempted, it is immediately blocked, logged, and alerts the security team.
So when you combine all those phases, discovery, mapping, granular policy creation, local enforcement, and continuous monitoring, you create an environment that perfectly embodies zero-trust architecture.
Exactly. We hear zero trust thrown around as a marketing buzzword constantly.
Oh, all the time.
But microsegmentation is the foundational technology actually making zero trust a reality.
Because the core principle of zero trust is never trust, always verify.
Right. Historically, if you were inside the network, you were trusted.
But zero trust flips that entirely. It dictates that no user, no device, and absolutely no workload gets automatic trust just because of where it happens to be physically located.
Or what network segment it is plugged into. Every single communication request is rigorously evaluated based on its cryptographic identity.
The health of the device making the request, user privileges, and the overall security posture at that exact moment in time.
And this becomes incredibly important when we talk about modern dynamic environments.
Because we aren't just dealing with a closet full of physical servers anymore.
Not at all. We are talking about sprawling cloud environments across VMware, AWS, Azure, Google Cloud Platform, and these massive hybrid infrastructures.
And that cloud support is really where the true power of this technology shines, isn't it?
Oh, absolutely. In the old days, a server was a heavy physical box bolted into a rack. Its IP address was static, and it just never changed.
Right. But today, a digital workload might be a lightweight Kubernetes pod that spins up for like 3 seconds to process a single transaction, does its job, and just vanishes completely.
Here's where it gets really interesting. If a digital workload physically packs its bags and moves from an on-premise server in a Chicago data center to an AWS cloud server in Tokyo, does the firewall rule literally travel with it?
Wait, don't.
If we connect this to the bigger picture, yes, absolutely.
Wow.
And that agility is the absolute superpower of modern software-defined infrastructures. The security policies are tied intrinsically to the workload's identity and its context.
So they are completely independent of its physical IP address or its geographic location.
Exactly. A centralized management plane orchestrates all the local agents. So if that workload migrates to Tokyo, its specific microboundaries, its hotel keycard permissions, move right along with it seamlessly.
That blows my mind a little bit. I mean, it is true identity-based security rather than location-based security.
We are moving away from caring about where something is and focusing entirely on what it is and who is using it.
That is the defining shift in modern network defense.
It is. And it helps to clarify an important distinction that often confuses people when they are designing these architectures.
What's that?
You will often hear the terms microsegmentation firewall and distributed firewall used interchangeably.
Yeah, I've noticed that. They sound like two different names for the exact same thing.
They are closely related, but here is the difference. A microsegmentation firewall describes what the system is trying to achieve.
Okay.
It is the end goal. Fine-grained isolation and strict communication control between individual workloads.
Right, so that's the objective.
Exactly. While a distributed firewall describes how those policies are physically enforced. It is the mechanism. It's centrally managed rules that are distributed out and enforced across various hosts, hypervisors, or workloads.
So you use a distributed enforcement model, utilizing those hypervisor interceptors we talked about earlier to achieve the ultimate goal of microsegmentation.
You nailed it.
That makes total sense. Okay, up to this point, this all sounds like a flawless, perfect solution to all of our cybersecurity woes.
But
But nothing in technology exists in a vacuum. We have to ask, what is the catch?
there is always a catch. The reality check for organizations deploying this is that it requires a tremendous amount of discipline.
And cultural maturity, I'd imagine.
Definitely. The first major hurdle is the initial planning phase.
Even with those automated discovery and mapping tools watching the network, designing truly effective policies requires a deep, exhaustive understanding of application dependencies, right?
Yes, if you're listening to this and managing a legacy network right now, you are probably sweating thinking about trying to map out a decade's worth of undocumented server dependencies.
Oh man, yeah. Ancient applications that no one currently at the company even built.
This raises an important question about the real-world danger of deploying this poorly.
What happens if you get it wrong?
If you do not map your dependencies perfectly first, you will accidentally block legitimate applications. You could literally take down your own company's operations while trying to secure them.
Wow. So if the billing server actually needs to talk to the inventory server once a month to reconcile accounts.
And your new microsegmentation policy blocks that connection because the passive learning phase didn't observe it happening.
You just caused your own denial of service attack on your own business.
Exactly. The operational complexity is massive. It's not just a technology problem.
It requires getting DevOps, network engineers, and security teams to actually agree on what a legitimate application dependency is.
Which is harder than it sounds. Large enterprise environments might contain tens of thousands of workloads. Managing and updating policies at that scale is exceptionally demanding.
Which brings up another critical limitation. A microsegmentation firewall is absolutely not a standalone security solution.
No, it is just one piece of a much larger puzzle. It has to integrate seamlessly with a whole ecosystem of other security tools.
Let's actually dig into some of those tools because they form the concept of defense in depth.
Right. For instance, microsegmentation pairs heavily with web application firewalls, or WAFs.
Because while microsegmentation handles the internal workload-to-workload traffic, the WA is sitting at the edge inspecting incoming HTTP web traffic.
Exactly. It's there to stop things like SQL injection attacks before they ever reach your web server.
And then you have endpoint detection and response, or EDR.
Right, because microsegmentation is incredibly powerful for stopping lateral movement across the network, but it does not replace the need to stop malware from executing on an individual endpoint or server in the first place.
That is what EDR does, right?
Right.
It monitors the actual processes running locally on the machine to catch malicious behavior.
Spot on. And we also have Identity and Access Management, or IAM.
Which manages the human side of things, making sure users are who they say they are before they even request access to a workload.
Plus, Network Detection and Response, or NDR, which uses behavioral analytics to hunt for hidden threats that might have somehow slipped past the other controls.
So you are basically building a layered defense. If one layer fails, the next layer catches the threat.
That's the goal.
So if microsegmentation provides all of our tightly controlled internal locked doors, we still absolutely need our security cameras, right?
Yes.
Which would be the SIM, the Security Information and Event Management System, aggregating all the alerts from those tools so analysts aren't overwhelmed.
Right.
And we still need our front gate guards, the perimeter firewalls, all working together.
You absolutely do. They all play a specialized role. The perimeter firewall is still vital for keeping broad, noisy internet traffic away from your internal assets.
But microsegmentation assumes that the perimeter will eventually fail.
Exactly. And it sits there waiting as the ultimate fallback, completely neutralizing the attacker's ability to capitalize on that failure.
It is a totally different paradigm. Synthesizing this whole journey today, we have really moved away from that flawed castle and moat perimeter approach.
We really have.
We're looking at a world where every single workload, every container, every application has its own personal identity-based security detail.
It effectively neutralizes lateral movement, trapping attackers in that digital closet before they can cause widespread damage.
And that transition is absolutely essential, right? As our networks become more complex, more distributed, and more reliant on dynamic cloud architecture.
The old ways of static IP-based filtering simply cannot keep up with the threat landscape.
This directly relates back to you listening right now.
It really does.
Whether you are actively managing the sprawling corporate network or you are just trying to understand why your company's IT policies are constantly changing and requiring more identity checks.
This shift from trust but verify to never trust, always verify is redefining how all of our digital lives are protected.
It is the new baseline standard.
It really is. And, as we look ahead, the rapid evolution of artificial intelligence leaves me with a final thought for you to mull over.
Oh, let's hear it.
As AI-driven anomaly detection becomes more sophisticated and autonomous, will we soon see networks that dynamically reorganize their own micro-boundaries during an active attack?
Whoa.
Imagine a system that detects a breach and instantly, without human intervention, starts shifting the digital maze in real time.
Just completely trapping a hacker in an ever-changing labyrinth of isolated zones.
Wow.
A digital maze that shifts around you while you're trying to hack it? That is a wild thought to end on, but it really feels like that is exactly where this technology is heading.
It's closer than we think.
Thank you so much for tuning into this deep dive. We hope this exploration into microsegmentation and zero trust gave you some serious aha moments today.
It's been a blast.
Remember to hit that follow button so you never miss our future deep dives. And definitely head over to WeCyberYou.com right now for more resources, insights, and content to keep you ahead of the curve. Until next time, keep learning, stay curious, and we will see you on the next one.